Hey guys, Mr. T here. This is another video on problem solving with simultaneous equations. Now, the greatest utility of simultaneous equations and just algebra overall is using it and using them to solve real life problems. So to solve these kind of problems, you need to follow the following steps. Pretty much from the book with a couple of extra little tips here and there. The steps are to decide on the two unknowns. Generally easiest to go with x and y, unless they're provided otherwise. The unknowns need to be decided by the important information provided in the question. You can't just go x and y and go, oh, these represent the number of hours or something. You need to think about it because they need to link together based on information provided in the question. And that may become obvious when we do the example below. Also, you need to keep in mind the units involved in those variables that you decided. Step 2, write down the two equations linking x and y, and they have to involve the knowns in the question. Your question cannot be answered if there's not enough information that is known. There are going to be bits of info or data given in the question that let you link x and y in two separate equations. You need to think through that. There's no one specific tip on how to decide on those. You need to use your head and decide based on mathematical knowledge and some common sense. Okay, and examples will be shown below and during classwork. Step 3, solve the equations with an appropriate method. So you've had previous videos showing how you solve simultaneous equations graphically, by substitution and by elimination. You need to choose one of those that best fits with the equations that you've created. Step 4, you need to double check your proposed solutions by substituting into the original question parameters. You can't just give the solution and go, that's the answer. You need to double check if they're realistic or not. And lastly, and also if they agree with the information provided in the first place. And now, lastly, you need to give the answer in sentence form. Don't just give me numbers as a solution. So let's run this example here. A machine tests solar batteries for faults. A working battery takes 2 minutes to test. A faulty battery takes 5 minutes to detect and repair, so you need 5 minutes to deal with that compared to 2 of a good battery. In an 83-minute session, 37 batteries were tested. So how many batteries were faulty? So straight away I'm looking at all of these numbers given, 83, 37, and trying to think how I'm going to link those together with the partial information that I've got here and variables in some way. I know the total time. I know the total number of batteries, so there's my in. You need to decide on the variables based on the two knowns that you have in the question. So how am I deciding that? Well, 83 minutes is a total time. Okay, 37 batteries is total units. That it's pretty quick to decide based on 37 batteries as total units what my variables would be, because I could say x is number of good batteries, and the other variable y is going to be number of bad batteries, and they're going to be linked with the number of total batteries overall. They're going to be, those two numbers added together are going to be 37. The trick is working out how I'm going to link the other information provided with the question with the number of good batteries, because I know the total time. Here, I don't know the total time it takes to do a good number of batteries, but I have an expression that lets me do that. Time to deal with all good batteries is going to be the number of the good batteries multiplied by the time it takes to test them. I don't know how many good batteries I've got, but I know that in total the time it will take to deal with them is going to be 2 times however many there are, because it takes 2 minutes to deal with them all. So there is my link, basically. I know that the good batteries take 2 minutes, and I know that I'm representing the number of good batteries by x. So the total time it's going to take to deal with just good batteries is going to be 2 times by the number of good batteries. So it follows then that times to deal with all bad batteries is going to be the longer time, 5 times by the number of batteries that need to be dealt with, which is y. So I've decided now that the variables x and y are going to represent the number of good batteries and the number of bad batteries respectively. So write two equations linking x and y and the knowns in the equation. So we need to formally state how these relationships, the number of batteries and the time to deal with the batteries, links with the things that we know. We know that the number of batteries tested, so the first relationship, the first equation is to do with number of batteries. The number of batteries is the sum of the number of good batteries you've dealt with and number of bad batteries, and we know that they are represented by x and y respectively. The known in the question that helps us with that is the number of batteries in total, which is 37. So there's my first relationship, there's my first equation decided. The number of good plus the number of bad is equal to 37 because there was 37 batteries dealt with in total. And time, the other known is the total time of the session, the total time spent testing. And we know the total time dealing with good batteries was 2 times by whatever number of good batteries there were. And the total time dealing with bad batteries is going to be 5 minutes times by the number of bad batteries dealt with. And that total time added up together is going to be 83 minutes for all of those batteries. So we have our two equations. We have our simultaneous equations ready to go. So you're at the stage of solving them. So formally write it with the curly brackets. Our simultaneous equations are x plus y is equal to 37. Our other equation is 2x plus 5y is equal to 83. Now these are both in general form. So you're pretty much, your go-to is going to be to deal with it using solution by elimination. So I'm going to look at x, and I'm going to look at their coefficients, 2, and this has 1, I just don't write it. What do I need to do to make their coefficients equal in size and opposite in sign? I need to multiply the top one by -2. I don't need to do anything with the bottom one because -2 times by 1 is going to be -2, and that is already the equal and opposite of +2 on the bottom equation. So that will lead me to -2x. I need to multiply all of the terms in the first equation by -2, -2y equals, and 37 times by -2. Feeling a bit tired today, so I'm not going to do that in my head. Times by -2, -74. We haven't done anything to the bottom equation, so it's left at that. We can add them together now. -2x plus 2x is going to be 0x. -2y plus 5y is going to be +3y. -74 plus 83 is going to be 9. So we have 3y is equal to 9. Opposite of timesing by 3 is dividing by 3. So therefore y is equal to 9 divided by 3, 3. We know half of the solution, y is equal to 3. We need to substitute that in. The easiest of the equations I have is x plus y is equal to 37. We know y is equal to 3, so x plus 3 is equal to 37. The opposite of adding 3 is taking 3, so do the -3 on both sides. Take 3. X plus 3 take 3 is 0, so we have x left by itself. 37 take 3 is 34. So I've solved them simultaneously. So at this stage, the solution is x is equal to 34, y is equal to 3. Let's double check the plausibility of that. What you would do is have a think about what we're talking about here. We're talking about number of batteries. None of these are negative numbers, so they're plausible, they're realistic. So in this case, the method of checking the plausibility would not be around whether it's realistic or not. You would be using the other equation to check if it still agrees with it. We're deeming x is equal to 34 and y is equal to 3 the correct answer, but we've only used the top equation to check that. Let's just double check if it's correct still when I substitute it into the second equation. 2x, and x is 34, plus 5y, and y is 3, is equal to 83. Is that true? 2 times by 34 is 68. 5 times by 3 is 15. 68 plus 15 is indeed 83. So plausibility isn't decided based on the realism of these numbers. They're all whole numbers. That would make sense for you to have 34 good batteries and 3 bad ones. It's not based on that. It's just based on whether the other equation is still correct, and we've determined that it is based on that solution. So provide answer in sentence form. Let me just double check what I said the variables were. X was the number of good batteries, y is the number of bad batteries, and my question was asking how many batteries were faulty. So therefore, based on a solution of x is equal to 34, y is equal to 3, 3 of the batteries tested were faulty. Okay, so that is a process of doing a problem-solving question using simultaneous equations. I've talked you through building up the equations, deciding what the variables have to be. I've gone through how you would check on the plausibility of the solution. The first step in checking the plausibility is deciding whether these are realistic numbers for the question itself. We're talking about real things, so these should be positive numbers, and they were. So there's definitely plausible. The second aspect of checking the plausibility was just checking that the second equation agreed, which it did here. And then the last step was providing the answer in sentence form, which we've done. So hopefully that helps you out, and I'll see you in the next video.